All right, so let us start with the introduction. This side, Mohammad Asib. I am the product executive at Digital Vidya. And today we have Kushal Wadhwani, who is currently leading the data science team at Visuary. He possesses 6 years of experience in leading software product companies focused on solving business problems using data. So today, Kushal will teach us about something, data science behind display ads in digital marketing. And the key takeaways of the session will be data science problems behind display marketing, understanding how distributed frameworks like Hadoop MR can be leveraged to solve data science problems, and realizing the power of featured engineering, and some other guidelines on how to choose ML algorithm. So over to you, Kushal. Please start the session.
Sure. Thank you, Atik, for the introduction. Hi, guys. The topic says it's data science behind display ads in digital marketing. I wanted to start with some motivation behind digital marketing. Right? So people nowadays are spending more and more time online on their digital devices, right? So the companies also have started noticing this, and they are moving a big chunk of their marketing spends to digital marketing. Okay, and at Visuary here we help companies to run their digital marketing campaigns and also power the technology behind the digital marketing. Okay, I work here as a data scientist, and I'll be in today's talk. I'll be talking about the data science part of the technology. Okay, and the goal is to give you I'll give you the understand the problem, and then slowly dig down in take one particular thing and then dig down. So the goal is to cover both breadth in the first part and then the depth in the later part of the presentation. Okay. So let's get started. Yeah, so as I told, at Visuary we help marketers increase their digital share of business. We have office in Dallas, Dubai, Bangalore, Singapore, almost all geos, and then our focus is on BFSI vertical, which most of our clients are banking and financial services, and the technology, the algorithms are also aligned to that. So all our features are like the security features and all the are basically aligned to the BFSI vertical. Okay, and so some of the, just to list down some of the clients that Visuary have. So all the big names in the business, basically Citibank and HDFC, CIMB Malaysia. So we work with most of the big banks and insurance companies across geos, basically. Okay. So what I wanted to do here is I'll basically take you through a use case, which so in this particular slide I wanted to take you through a use case which is solved by digital marketing. So this particular use case is bring back a prospective user. So this is one use case, but there are other use cases like bringing a new user or just running an awareness campaign through digital marketing or a branding campaign through digital marketing. Okay, so in this particular use case, it's basically bringing back a prospective user. So suppose a user visits HDFC website and browse some products, say browsed for a personal loan. Okay, and then drops off without submitting a lead. Okay, so banks to take action further on the user who is a prospective user browsed his website needs the phone number or the email which banks captured while submitting the lead. Okay, so the major purpose is not served. It was a prospective user who just browsed, has an interest in the product but has not submitted a lead. Okay, he just drops off without submitting a lead. Where Visuary comes in is Visuary basically has a publisher network, which I'll talk about in the later part of the talk. But we basically show ads to this particular user with personalized banners and codes, okay, which attracts users, and then user finally clicks on the banner and then lands back on the HDFC website and hopefully submits a lead. Okay, so this is one use case. So yeah, so moving further, so that was a use case. This is how these are some of the channels which we power, and these are some of the channels which we use to bring back users. Or one is programmatic. So programmatic is basically user. So all the blogs and the news websites which you visit, you might be seeing a banner ad on that. So that particular channel is called programmatic, the whole channel. And then we have also integrated with social media, which is so platforms like Facebook and Instagram, where we show banners to the users. And there are other channels like mobile push notifications and web push notifications. So so in this particular talk, I'll only be focusing on the programmatic part of it. So each channel has its own technical challenges and data science challenges. So I just wanted to focus on one of it, and then just to cover it in the depth. Okay. So we'll in today's talk we'll focus on programmatic, which is the blogs and the news websites, or over the internet, the banner ads which you see. Okay. Yeah. So I wanted to explain the programmatic flow, how it actually works. Okay. So whenever a user visits goes online or visits say a news website, there is a banner on it, and which requests the ad server for the ad. Okay. This ad server then redirects to the ad exchange. So ad exchanges of the world are Google, AppNexus, Yahoo. So they basically do a auction for this particular ad, and then they set the this particular request to the bidders. So bidders are, so Vizuri is one of the real-time bidders. So since we want this ad slot, we want the ad slot to show the banner, we bid for this particular ad slot, and we bid based on the user and based on the ad slot. So we evaluate whether this particular user is going to click, or just see what is the probability of this user clicking on, and also evaluate the probability of this particular ad slot being clicked. Okay. And then that's how we send a bid request, or the bid value, which is the actual price money which we send to the ad exchange, and there's an auction. So which we can lose or win. Okay. In the case we win, we get to show the ad. So this is the whole programmatic flow. Okay. I'll just pause here, and you guys can just go through the steps of it. So all this happens in 100 milliseconds actually. So this is all real time, happening real time. Okay. So now let's look at, so I already mentioned, like let's look at the optimization problem behind this whole programmatic flow. So on one side we have ad exchanges, publishers, where publishers like Google, AppNexus, and Brightroll, Yahoo Brightroll, where we pay them per impression, right? We pay them for showing an ad. Okay. But on the other side, we have clients like where we have to maximize the clicks for those clients. Okay. So so obviously there's an optimization problem here. So we have to only spend money where we know we are sure of getting the clicks. Okay, and since we have an optimization problem, there are parameters to optimize. Okay, uh, so the parameters to optimize here are what is the bid value. Okay, so bid value, as I mentioned earlier, depends on two major factors. So two chunk of variables. So the one chunk is the user variables, that is how probable is this user on clicking, and then the second is the property of that ad slot getting clicked. Okay, so these two uh, basically defines our bid value. So bid value is basically directly proportional to the probability of click given ad slot and a user. And since bid value depends on other factors also, but this is one of the major factors, the probability of click. Okay, and in our terms, we call this probability of click as CTR, also known as click through rate, which is nothing but a percentage of probability and 100 into the probability. And so for all the further discussions, I'll be only I'll call this probability as CTR. Okay, the other uh, the other the parameter which we have in hand to optimize is what to show. So once we win the bid, uh, we have to show a banner, right? And that also influences the property of clicking, right? If the message, if the banner is relevant enough, is attractive enough, is big enough, then the user the property of clicking is more. Okay, so but so I'll not be talking about what to show part. I'll only be talking about the what to bid part, which is basically probability of click. Okay. So yeah, just to recap, like we saw a sample use case, and then we saw on what all channels we can target, and then we drilled down to the programmatic channel. We understood the flow of programmatic and the optimization problem behind programmatic, and uh, basically the parameters to optimize. Okay, so now
So Kushal, let me create one thing in here with the participants. Actually, we have questions coming in, and one thing I would like to create here is that we'll be taking questions at the end of the webinar. All right, so you can note them down, and we'll answer your questions at the end of the webinar. All right, Kushal, please continue.
Sure. Yeah, so I was just recapping the whole thing. So basically the programmatic flow, and then the parameters to optimize. Okay, and then which is basically bid value, and bid value is directly proportional to the CTR. Okay, and then the so I'll be now talking about the data collection and processing part of it. So behind this, there's this whole plethora of data and learning going on, right? So I'll first take the data part of it, like uh, so how do we collect, how do we process the data, and what type of data do we collect? Okay. Okay. So in the data collection part of it, I thought it will be easier to show it again by the use case that I covered. So whenever there is a activity on the client's website, in this case I have taken HDFC, we have a activity log coming in, okay, which we store in user activity database. And wherever there's a activity on the publisher side, which is basically in blogs or news websites, we get a bid request, which we log in bidsdb. And further, when we show an impression, when we win the bid and show an impression to a user, we log it in impressions, DB. So, and whenever there's a click, we have a click database. So these are some of our data sources on which we collect the data. Okay. And so now I'll go into the variables part of it. Like when I say user depends on user, so what variables of user it depends. When I say it depends, or CTR depends on the ad slot parameters. So what parameters are those? Okay. So some of the user variables are like time spent on website. Okay. So if a user has spent, say, browsed, say, 2-3 pages and then dropped off, will be less probable to click. But versus a user, say, who has browsed for significant enough time, looked at all the details, read the descriptions, will have a higher probability of clicking, right? So these are some of the user variables which influence CTR, like time spent on website, number of products he has visited. So these are website level parameters, and there are some channel level parameters, like we have how many impressions have we shown to this user already, and like how many clicks have we got from this users. So if a user has never clicked, the probability of click for that user is low. Otherwise, it's high if he's a frequent clicker. Okay. So these are some of the user variables, and the second are the ad slot variables. So ad slot variables are like size of the banner. Okay. So suppose it's a small banner somewhere sitting bottom right of the page which you are browsing. The probability of that getting clicked is low. Okay. Versus, say, if it's a big banner on top of the website, the probability of it getting clicked is higher. Okay. So size of the banner and the visibility of the banner is one of the variables. And URL of the ad slot is for example another variable. Like say people on Times of India clicks more than NDTV. Don't know, just putting it out. But yeah, the URL is also one of the variables, and there are many such variables. I'm not listing all those down, but this is just to give a glimpse of how the variables will look like. Okay. Cool. So this is the interesting part. So we have some ad slot variables, some user variables. Okay. And we also have historical data, which is like in general which type of variables got clicked in history. Okay. And for that we also know like the click flag, whether it was clicked or not. And then the problem is basically there are new bid requests coming in every day with these variables, and then you have to predict what is the chance of these getting clicked. So the question mark here is basically what we have to predict. Okay. And so if you see this kind of table, it should instantly come like into your mind that it's a classification problem. Okay. So where you have some input variables, and then the output variable is basically a flag, 0 or 1 flag. Okay. And so that becomes your training data, and new bid requests are coming with the variables is for what you have to do the prediction. Okay. So in our case, it's a class. This is a classical classification problem. So it has around 50 to 100 variables, both numerical variable and categorical variables. So just to give an example, time spent on website is a numerical variable. Okay. And say a size of a banner is a categorical variable. Okay. And the scale of the whole problem is huge, because we have billions of bid requests coming in, and then millions of impressions we are serving daily. So it's not a single machine problem. Okay. Just to highlight that fact. Sure.
Okay,
So,
Kushal, let's take a pause in here. I have to launch a poll to get participants' feedback, and it will take only a couple of minutes.
sure.
Yeah. Okay, so guys, I would like to launch a poll, and please just reply yes or no to that. Can you see the poll in front of you? If you are interested in big data analytics course, then please provide your answer to this. Let us continue with the webinar.
We came to the point where we understood the problem is a classification problem where we have some input variables and then the output is basically a flag. So I wanted to cover some of the quickly cover some of the widely used algorithms for machine learning algorithms for classification, and the idea is to not give the theoretical background about the algorithms, but to tell you what basically what are the assumptions behind the algorithm, in what cases it can be used, and like what are the advantages and disadvantages of those algorithms. Okay, so yeah, so start with logistic regression. Logistic regression is one of the, like, I'll say, the most widely used classification algorithm. So the formulation is basically the equation which you can see is very similar to the linear regression algorithm which we solve, wherein the only difference is instead of y on the left hand side, we have a log of odds ratio, also known as logic. Okay, so we learn wt here, okay, which is our weights vector, to and basically get the to get the probability from the y, basically just put we add a sigmoid here to get the probability. Okay, so this is a modified version of a linear regression problem. And so coming to the important part of it, what type of data can it handle and what kind of data it has challenges, it faces challenges. So since it's a linear regression, it handles all type of linear interactions between the variables. So suppose you have a variable x1 and x2, and your output is dependent on some linear combination of this on these two variables. The logistic regression will be able to capture that. Okay, the second big advantage is that there are already quite established scalable algorithms available for training logistic regression. Okay, and it also handles all the high cardinality categorical variables. So when I say high cardinality, so like categorical variables which have let's say tens of thousands of values. Okay, so that's the scale I'm talking about. So logistic regression normally handles it. So and then the disadvantages are, so when I say disadvantages, it's not hard and fast key, it will not be able to handle it. It's just that it's not able to handle it out of the box. So there can always be some tweaks done to the variable to make it fit, to make it adaptable to logistic regression. But out of the box, it is not able to handle it. So the first thing is so the first disadvantage is assumes the variables are linearly related to the log odds ratio that is visible from the equation which it's solving. So it assumes a linear relationship between variables and the log odds ratio. Second is it does not handle the nonlinear interactions, which is say two variables x1 and x2 are non-linearly related to your output variable y. Okay, some 2-degree equation, or it can be anything. It, it will not be properly captured by the logistic regression. Okay. The second most widely used is are the decision tree based models. So random forest and XGBoost comes into these categories, and these are very widely used classification algorithms. And the training is different here compared to logistic regression. Here basically we it, it so it basically trains a decision tree in which each node is a variable, and then based on the values of that particular variable, it splits the node, and then basically the leaf of the node has the probability of whether the property, or the in our case it will be yes or no. Okay, so in random forest and XGBoost are some variants of basically decision tree only. They use decision tree inherently to basically come up with the properties. Okay, coming to the important part, so the advantages is are it handles nonlinear correlation of input and output variables nicely. So if a variable x is say it's not linearly proportional with y, then the decision tree models are able to handle it out of the box. And it also handles nonlinear interactions, which was not possible in logistic regression. And the other key advantages is that the models are intuitively easy to understand and explain, right? So because it's a tree, you can look at it, and then intuitively you'll have an understanding what is happening, and also explain it to others. So that is also that helps in when you have a bigger team and you have to explain it to someone, right? So the challenges again, it fails in case of high cardinality categorical variables. Okay, so again, out of the box, the decision tree based models doesn't handle high cardinality variables that properly. So again, the high cardinality here is hundred of thousands, so tens of thousands of the cardinal is tens of thousands. If it's say 10 or 20 or 100, and according to best of my knowledge, around it also handles some variants of XGBoost, and random forest are also able to handle till 1000, but not beyond that. Okay, so this is one of the main challenge in decision tree based models. Okay. The third, which is becoming very popular nowadays, is neural nets. Here, so basically in between the input and output layers, there are some hidden layers. Okay, and each neuron of hidden layer is connected with all the input layers of all the input variables. So basically it gives this particular structure of the neural nets gives the power of understanding like the correlations between all the input variables, and also the multiple layers helps it to capture the nonlinear behavior of the variables also. And so most of the disadvantages of logistic and random forest are gone here. So it can handle linear correlation, it can handle nonlinear correlation, it can also handle nonlinear interactions of the variables, and also works well for high cardinality categorical variables. The only disadvantage is the models are not readable. So like it's a graph which you not, I mean, by looking at it, you will not be able to make sense of it. Okay. So yeah, so these are three major widely used classification algorithms. And so in the next section, what I wanted to do is basically I'll take some variables, okay, and basically visualize those, plot some distributions, plot the correlation between a variable and the CTR. Okay, just see what type of correlation it is, whether it's a linear correlation or a non-linear correlation. And in case of categorical variables, see how is whether the categorical variable is adding value, does it has a CTR variance or not, or and just see the cardinality of that categorical variable. Second is, once we have all this insight by visualizing the variable, like how to pre-process the variable, and then evaluate the variable against the ML techniques which we just discussed, the 3 ML techniques. Okay, so this is going to be the flow for like 2-3 variables which I'll be explaining. Okay. So in this particular slide, I have plotted 2 numerical variables. Okay, variable 1 is on the top and variable 2 is on the bottom, and I have plotted distribution and the correlation of both the variables. Okay, and as you can see, both the variables have skewed distribution. Like it's not uniform or it's basically skewed, left skewed distribution. Okay, and the correlation part also, on the x-axis we have the variable value, and y-axis we have CTR, and so the correlation obviously doesn't seem to be linear, right? So in the case of variable 1, the value first drops and then flattens and then increases suddenly and then gradually flattens out, right? In case of variable 1. In case of variable 1, variable 2, it starts the gradient is very high initially, and then slowly it goes down, flattens down, and then finally flattens down to almost 0, the gradient. Okay, so both the variables are not linearly correlated with CTR, and also doesn't have a normal or a uniform distribution. They have a skewed distribution. Okay. So these are the problems with these variables. These have skewed distribution, these are nonlinear correlation. We'll see how to handle those variables. Okay. So yeah, so handling the skew and the nonlinearity. As mentioned in the logistic regression slide also, out of the box, logistic regression will not be able to handle nonlinear correlation and the state distribution. But decision tree based models and neural network based models will be able to. Okay, and but in general, if you're feeding it to a neural networks also or a decision tree models also, if we know that the variable is behaving in such a way, it's better to pre-process the variable. Okay, and these are 2 techniques by which we can pre-process a numerical variable which has a skewed distribution. Okay, one is the log transformation, wherein we just take a log of that variable during training and also testing, and other is we can bucketize the variable and create, say if a variable, I bucketize the variable into 5 buckets, I can create 5 new variables out of this one variable, which are less skewed and or maybe have a linear correlation. Okay, so I have plots for this log transformation and bucketization both. I'll just quickly go through it. So I have taken variable 2, which I showed earlier, and again plotted the distribution and correlation. And the top part says how was the variable behaving before, and then after log transformation, basically the distribution is still on the skewed side, but relatively it has come down, the skewness has come down, and we can see some big buildings in middle of the variable 2, right? And the correlation part also, earlier it was visibly nonlinear, and so which is now comparatively linear, at least in the sections where the density is high for that variable. Okay. The other part is the second technique of handling skewness and nonlinear correlation is bucketization. Okay, so what I have done is I have put lines where this variable can be intuitively bucketized. So in within the line, within the bucket, the correlation seems to be linear, right? And what it does is it also uh, reduces the skew of the variable within the buckets. So in the bottom section I have plotted the variable within the buckets, and just see the distribution within the buckets, and comparatively it looks like very less skewed compared to the original distribution which we plotted, right? Bucketization can be, there are various ways to do bucketization, but yeah, we'll not be covering it, but this is definitely one of the pre-processing steps for skewed and non-linearly correlated variables. Okay. So we saw variable 1 and variable 2 individually. I just plotted variable just to see the interaction between those two variables and how the CTR behaves when these two variables interact. Okay, so in the above section I have variable 2 on x-axis and variable 1 on y-axis, and the size of the circle is basically representing the CTR. And as you can see in the right quadrant, the sizes of the circles are non-linearly high. Like it's basically increasing at a non-linear rate compared to the left side quadrant or the below quadrant. So that says that these variables, the interaction of these variables affects the CTR, and it's not a linear trend. Okay, and when you come to the triage part of it, yeah, again logistic regression out of the box will not be able to handle this non-linear interactions, but decision tree based models and neural networks will be able to handle this out of the box. Yeah, so here I have two categorical variables. So I've been mentioning high cardinality categorical variables, so I have plotted one here. So on the left hand side, there's a categorical variable 1 which has a cardinality of 10 raised to the power 4, and on the right hand side there's a categorical variable which has a cardinality of 10. So what I have plotted here is I just took the CTRs of those variables and did a box plus density plot of it. So the width of the section is showing the density of that variable at that particular CTR, and then the y-axis is the CTR variance, like how the variance of the CTR is for that particular variable. So looking at the distribution in y-axis, you can say that this variable is definitely important, and it has a CTR distribution, and also yeah, and for the variable 2 again there is a decent spread on the y-axis which says this variable is definitely important, and changing the value of a variable is changing the CTR, but the cardinality is on the lower side. Okay, so both the variables are important, and we can't ignore, since the cardinality of variable 1 is important, we can't ignore the variable. We in our case we have to use it, right? So we'll see the triage part in the next slide. I have plotted the interaction also of both these variables. Okay, so on x-axis is categorical 2, variable 2, and on the y-axis is the CTR spread of variable 1. Okay, so I have only taken those values of categorical 1 which are overlap with the value 1 of categorical 2, categorical variable 2, and so on. So I have plotted 6 different graphs here. So what to interpret is basically there is an interaction between variable 1 and variable 2. and the CTR spread and the density both are changing when we are changing the values of categorical variable 2, right? The CTR spread of variable 1 is changing when we are changing the values of categorical variable 2. So there is definitely a interaction going on between both the variables, right? Coming to the triage part, so high cardinality categorical variables, logistic regression can handle, but yeah, this is the most critical part, that decision tree based models, which are good in all the other aspects which we have discussed till now, we cannot handle high cardinality categorical variables of 10 raised to power 4 order, and yeah, interactions is same as the interactions of numerical variables. Both decision tree based models and neural networks are can handle interactions between categorical variables also. So this is like I just wanted to cover it here. So just to for the completion sake, that the neural networks and logistic regression, they don't out of the box, like they don't, we can't input a categorical variable to it directly. I have to either do a one hot encoding or replace the value with the class weight, or in our case it's CTR. So instead of the variable, you can use the class weight there, and the both have their disadvantages. Like in case of one hot encoding, we are creating one new variable for each categorical value, and in case of replacing it with CTR, the will be missing the interactions with the other variables, because now we have replaced that particular value with the CTR, a numerical value. Okay. So coming to the evaluation metrics, so once we do the training, how do we evaluate the model and how good it is or bad? So AUC is one of the metrics which we look at like right away, which is basically a 2D plot between, also known as area under curve, and it's a 2D plot between the false positive rate and true positive rates. And so if it's a random model without any intelligence, the AUC will come to be 0.5, which is that dotted line on the graph. But if the model is good, the area under curve basically goes high, and more the area under curve, better is the classification. Okay. The only catch here is it only quantifies how the model has ranked your or rank your records, but not the actual magnitude of the value. Okay, so along with AUC, we also see some of the metrics like log loss, which kind of capture the magnitude of the variables, so the probability and the flag which we have. Okay. So summarize. So we understood the data science problem behind programmatic channel, which is basically a classification problem, identify CTR and build accordingly. We looked at some of the ML techniques which is widely used for classification. Did some visualization and some feature engineering, and had some guidelines on how and which model to choose in which case. I also looked at some of the metrics to evaluate. I'll open for Q&A.
Yeah. Okay. We are open for the questions. Please put down your queries in the question panel. I request everyone to start posting their queries in the question panel. Yeah, hi Rajesh, please type your query. Yeah, we have a question from Kaveshri. Um, please elaborate your question, Kaveshri, what actually you are addressing. Which methods are you actually addressing? Is it about machine learning or algos? Yeah, Kushal, I hope you can better understand this query. Kaveshri is asking why these methods are used. If you take a look at the question panel, the timestamp is 3:49 p.m.
Kaushik, can you type out the full question so I can see this methods here in the question, but not the full question. I think if you are able to see the
the question is in here.
yeah.
Yeah. She is asking about the terminologies. Okay, Kaveshri, I think your question is pretty generic. Do one thing, please forward your query on the email in which you have got the link to this webinar. So you can put on your query in there and we'll get it answered later on. All right. So I request all the other participants to type in their queries so that we can answer them in real time. Does anybody has any question? Let us just wait for another couple of minutes and we can wind up with the session after that. In the meantime, I'm launching a poll. So guys, please provide your vote to this poll.
Also, if you have any questions, you can reach out to the email ID I mentioned. Any question regarding the about Visuary or about the technology part which I explained, you can reach out to me on the email.
Yeah, there is one question, Kushal. It is from Shivam. Shivam is asking, is Facebook do same thing for showing advertisements?
Okay. So, uh, yeah, I mean, I don't know the exact details what Facebook does, but yeah. So when we do from Facebook, we do through Facebook. Yes, it's almost the same flow. But if you are asking how the Facebook handles the direct campaigns, that I don't have much detail on it. So if the client is running through us, then yeah, there also there's a CTR factor involved. But if the client is directly running on Facebook, then no idea about that thing.
Okay, so let us just wind up with the session. And I would like to thank you, Kushal, for taking time out for this really enormous and informative webinar. And we'll surely forward the queries to you whenever we get those from the participants. And for everyone, I would like to again request you all to please forward your queries to the email thread in which you have got this link to this webinar. All right. Let's wind up with the session. All right. Thank you. Have a nice day ahead.
Bye.